Okay, thanks for coming back, guys. Very long title, thanks to Johnny, because I couldn't come up with one before he wanted to release a schedule, so this is what we're working with. Quick introduction. So I'm Olaf, I'm from the Netherlands. I work at a company called FalconForce, where we do a lot of things in security. So we do advanced red teaming, and we do a lot of detection engineering and security research in general. So I play with Defender a lot, which this talk won't cover almost at all. And I have a history as a photographer. So I went to art school, did all kinds of stuff. Last summer, I was in Slovenia and I drove through Log, which was amazing. This is also the city itself almost. There were like 4 houses, so it was really tiny, but I pulled over and got my kids to take a picture. So that was fun. I'll try to stay away from the speaker. So I'm going to talk about graph again. I think it was introduced by Henning already. There he is. So I'll briefly explain what graph is and why you may care. So I start off with a simple example. So there's a couple of names that you need to remember, right? So an object in a graph is called a node. A node can have a type, or a label in most cases, like Henning explained. You can have multiple labels even. Nodes can have properties as well, so you can have all kinds of data on it, like a name and an age and all kinds of other information that you care about. And the connection between 2 nodes, or the relationship between 2 nodes, is called an edge. It's just, I didn't come up with these things, but it's just the way we have to deal with it. And these can be all kinds of attributes. So in this case, Bob likes Alice. And this can go further, right? So one of the most important things is that an edge is directional. So it's a single direction. So Bob can like Alice, but that doesn't have to be mutual. In this case, it is, right? But it can also be something else. And that's very important when you're playing with graphs, is there's no assumption of a bidirectionality there. So there have to be 2 edges for that. And even an edge can have properties. So in this case, Bob is older than he looks, or maybe his age is incorrect because he was playing Commander Keen for a long time. If you're equally old as I am, then you also played that. If you don't know what I'm talking about, Google it. Anyway, it was a fun game, and he has a certain skill level, right? So that can also be a property of an edge. A more applicable one to our context is that you can also be a member of, in this case, the Scouts, but you can also be a member of a group. And that can be since a certain date or whatever the property may be. So you can have all kinds of properties on top of your edges. And the reason why that's useful is sort of, if we look at Azure as an example, you can have an Azure tenant that contains a user. It also contains a group. But these groups can also have a connection with the user, right? So the user can be a member of a group. There can be way, way, way more. So this is, if you expand that a little bit, it looks like this. It doesn't look like this because there's way more properties and edges and interconnections. But this is sort of how fastly it can spin out of control. That's sort of why I created this smaller image. So the tenant contains a group, but the group can also have a role assigned to it, and that role can be a contributor to a subscription, and so forth, right? So nobody can remember this stuff, so this is where graphs are extremely useful. And I'll have a couple of examples why I care so much about this. Couple of operators that are quite useful if you want to work with a graph in Kusto. So you have the make graph operator, which creates a graph in memory. So basically you feed it tabular data, so just a couple of tables, and it will create a graph for you in memory. If you want to query that graph, then you use the graph match command, and basically it will go through it, and you have to return some data, and then you get a table back. There is a preview feature that's called the graph shortest paths. So there is an equal function in Neo4j where you can say, give me the shortest path or all shortest paths. This is basically the ladder. So it will give you all the shortest paths. So if there are 5 paths with an equal short length, you will get all the paths back, which is pretty epic because it's super quick compared to what Neo4j does in my experience. And you also have a graph to table function that seems to convert a graph into tabular data. I've never really played with that. And in Henning's talk 2 hours ago, I also found out that there was like a couple of other functions like blast radius and others that I didn't know about. So I played about with them in the previous talk. And I have a small example of that, how that can be useful. It's really, really nice. So there's basically, how I describe it, 2 graph types in Kusto. So you have a dynamic graph or a mixed mode kind of graph where you can mix a certain list of nodes from a table with even live results from another query. So you can mix query results in your graph. So you don't have to have the data ready to go yet, but you can also have it as a sort of dynamic moment in time kind of query, which can be very useful, but also very confusing, but at least be aware that it's there. And it does require you to query in a very efficient way because you're querying data. That data needs to be processed in memory as a graph, and at some point it spirals out of control, right? So you need to be very conservative in the data that you actually give to the graph, because the more you give, the more memory it consumes, the harder it is to calculate all these relationships or edges. And at some point, it won't be happy anymore. But it is super flexible, right? As long as you keep that performance risk in mind, it's super nice. On the flip side, at least in ADX, I think that's the only place where you can actually play with snapshots, is you can do the same, and then you can create a moment-in-time snapshot. So this can be super useful, as Henning already explained, to compare a state between what is current and what it was like at the moment of the incident, or you can have like that, at least when the incident happened, everything looked like this kind of thing. One thing to keep in mind is you also need to have a maintenance window around it, because if you create snapshots, they will incur disk space. Disk space is cost, and at some point there's a limit to the amount of snapshots that you can have that I'll get back to later. So you also have some lifecycle management to do, like with everything else, right? We all maintain our detections, of course. So that the same applies to graphs. The only thing is, as far as I know, snapshots are only available in Data Explorer. Looking at you. Event House. Okay, yeah, that's Fabric, right? But not in Sentinel Data Lake or any other solution yet. They may come, but I don't work at Microsoft, so don't ask me. So when you create a graph, you have to query it. So there's a couple of things that you can do. You can use that make graph thing to create a graph and just immediately do a graph match on top of that. You can create a function out of it, so it's easier. You don't have to remember that. It's kind of nice. You can also create a model, which I'll have a demo of in a second, where you can also define the model of your graph, how it should look, what the interconnections are, what the labels are, all these kinds of things. And you can just call it with a single command, which I prefer the most because it's the most flexible in that sense. And you can use snapshots on top of that. So these models are really nice. There's a couple of things that I learned the hard way. I see Henning smiling. So if you create a model, there's sort of 2 ways that you can query that model. So if you do this, it will run the last created snapshot that exists. If there's no snapshots, it should go to the live data set. So it will be a bit slower, but at least you should get results. If you are like me and you're not aware that you created a snapshot at some point while experimenting, or it got created automatically, then you're looking at old data. So I was running into an issue where I thought I found a bug. And with some debugging with Henning, it turns out that I had a snapshot that was querying from like a very old data set. So the stuff I was looking for wasn't in there. So be aware of this. So if you don't get the results you expect, then basically put it into transient mode, where you can say, hey, the transient mode is true, so it will always query live data. So if you see differences, you can basically put the true there. You can also, instead of a true, place the snapshot name that you've created in there, and then you create a certain snapshot. So if you have a naming convention based on date or whatever you like to use, you can basically use that to go back to a certain moment in time. So that's basically this, right? So you put it there. The cool bit there is that it will be persistent, it will be quicker, because it can immediately query, it doesn't have to build the graph. So it will be really nice. And the really good thing here for security people is, especially with the stuff that comes after, you can basically compare states or see progression or deterioration, hopefully not, but you can basically see the current state of your landscape compared to what it was a month ago or something like that. Or let's say you had an incident 3 months ago that you weren't aware of, you're investigating it now, you could actually look at what your Active Directory looked like at that moment, which is a super unique feature if you compare it to Neo4j or other things that I'm not aware it's possible. And this is what I mentioned earlier, right? So to definitely make sure that your graphs stay up to date if you create snapshots and you delete old ones at some point. Because Microsoft lost money, so do you probably, and you want to keep it. So make sure that you keep that. So at some point you can basically query the graph. You can do that in several ways. This is the KQL way, where you say graph match, and you give it a source node, a relationship with a length that you can specify, and then a target node or something else. And the confusing bit for me still is, I'm very used to Cypher or openCypher, so I was super happy that it was announced, because there you can immediately specify, for instance, on the source node, it has to be a user or whatever. You can also specify the label. As far as I know, you can't do that directly here. You have to do a where clause afterwards, which I'll show in a second. But these names are just arbitrary, right? I can also do fluffy bunnies, whatever. And you can come up with your own naming scheme, and just make sure that if you share that with people, that they also understand your thought patterns. So then you can do a where, so you can refine your search. So the user contains a certain node name and a certain label. And also here, not like everything else in Kusto, or KQL, sorry, you don't use a pipe. So it has to be a single sentence, which sometimes goes wrong. But you get used to it because it shouts at you that you're doing it wrong. So that's at least helpful. So, but you have to specify like the whole path within any node or edge that you have, right? That's why the user.node name is there. It's just a sort of JSON object. But you have the same flexibility of in and has any, and there's quite a lot of nice features there. So if you're very used to KQL and never done Cypher, then this is perfect for you. So the next step you do is you also have to always project some data. So you can search, you can have a match, or you refine your match, and then you also have to generate your output, where you can do the same. So in this case, I'm projecting the node name for the user. I do the path, so the labels only, and then some additional data. So you have to really know what you want to output, ideally, if you want to have useful output from it. You can also just output the whole node, edge, and target node, but then you get like huge JSON arrays for all the properties and information that you have. So an example from the Microsoft website, so you can have like 2 tables, employees and a reporting structure. And then you can query it in a way where I want to see all the people that are under 30 and report to Alice. And you get a table back that looks like this. So like, hey, Joe has a direct report to Alice, but Ben reports to Alice via Chris. So you can have these smaller paths this way. You can also format it any way you like. So you can also add some table in between where you have like these nice arrows and these kinds of things. You can just inject that into the results. But this is what you would get from like a standard Kusto output. So there's a couple of things to keep in mind if you're working with graphs. They're not that different from working with KQL in general. You still need to filter as close to the top of your table as possible, right? So basically the bottom line is the least amount of data into your model, which you don't need. So all the stuff you probably don't use in the result, maybe don't feed it into your model, because that's going to incur way more memory, right? The more columns, the more it has to expand. So that's still a thing. Also, if you're having JSON objects in your nodes and you only care about a couple, just extract them. Just have a couple of columns instead of like huge arrays. This is going to be quicker when evaluating it. And the same with just if you can summarize your data in any shape or form, do it. I think for all the stuff I'm going to show you next, that doesn't really apply because it's all single connections. But if you have that, that's kind of interesting. Other stuff I found while researching and sometimes reading the documentation is it's all in memory on a single node currently. And that also has a sort of RAM limitation. So if you have a huge data set, then you have to think about what you're going to be graphing, because at some point the node will run out of memory and you won't get results. So that's, again, same with a lot of other KQL stuff. There's also limits to the amount of snapshots you can have. So what I could find is like there's like 5,000 snapshots you can have per database, which is quite a lot. Even for the free server, you get 500. And the limit I could find that it can take for the creation of a snapshot, that's an hour, which is for most data that I've been working with enough. But it really depends on your data volume that you want to put into it. But be mindful of that. There's also the shortest path one that I was hyping earlier has some limitations. So if the path is too long or too complex and there's too many interconnections, that at some point it will break as well. I haven't ran into that yet, but there's probably a limit that you will run into if you really start playing with this intensively. And also, the result data can never be bigger than 65 megabytes or 500,000 records, which is quite a lot, right? If you're not going to render 500,000 nodes and edges, or at least 500,000 paths in the way I usually generate it. If you do that, then you have a query problem in the first place, right? So you don't want to see that. And the way I'm currently using it, I won't see it because my UI will just break because it can't render that, because I'm not using the graphics tree that Henning showed you. And there used to be a limit of 10 million nodes and edges combined. I think it's raised, but I couldn't find any documentation. Do you know it by heart? Oh, there's no limitation now. Okay, perfect. Well, I can scratch that line. So there's no limitation anymore. You can just, as long as you stay within the 500,000 records when you return it, whatever you feed it, depends really on, I think, then the complexity of your data set. So if it's too voluminous, then the RAM of the source node will crash. Okay, so that was sort of what is graph, or why you want to graph. So then, just as a thought experiment, I thought, okay, let's say I can graph anything for security, what would I want? So the exposure graph could be quite interesting, right? It has already graph in it. Thomas will go very deep into that later. But there's also all kinds of other things you can think of, right? Let's say you have an alert or an incident, you want to find patient 0. You can do a lot of Kusto querying, or you can maybe build a graph and figure out, like, hey, where did it start? Of course, you can do all kinds of other things, like, hey, which machines have the same vulnerabilities, and do they have sort of a path to something else? Of course, you can do attack paths, that's why I'm here. But there's all kinds of things you can think of, right? You can even build like a network topography where you can see data flows going through your network, these kinds of things, depending really on what you're interested in and what you are capable of writing. So one of the first ones I started playing with as an experiment was incident graphs. So this is a very basic example, right? You should definitely expand this. But basically what I'm doing is I'm dynamically creating my entities, so my computers in this case, right? But you can do this the same for hashes, nodes, programs, whatever you like. Then I have a list of alerts, so all the unique alerts that I have with the relationship between them. So I'm combining all my alert titles with my entities and with the relationship between them. And I'm creating a graph about it, and I'm querying it. And I'm basically getting then a result that looks sort of like this, where I can see, so let's say this is my computer. I have 3 alerts on it, but they also happened on several other machines. So that could be very useful for analysis. You can also do this in normal Kusto, of course, just create a table. But as soon as it becomes bigger and you start introducing all kinds of other entities like hashes, programs, and these kinds of things, you can see interrelationships between these things. So maybe this hash was also seen on another machine, so you can see those connections as well. And you can do that with Kusto, but this is a more visually appealing way. part of this Defender XDR has this, but never seen it working really well consistently. But it might be an interesting thing to do, right? And you can do this all automatically and only show if there are like multiple connections, these kinds of things. And you can start adding stuff, which you can't do in XDR by default. So you can maybe generate a process tree. You can maybe enrich that hash against your email logs and all kinds of other things. So you can actually see, it's like, hey, this hash came from an email, then it was executed on this machine, and it also generated alerts on other machines. These kinds of things that you could think about. So that is one option that you could play with. Another one that I was kind of interested in, since it has graph in the name, I started looking at the exposure graph. So basically what is in there, in my experience, is like a whole list of findings that Microsoft has in your environment. So it could be, hey, you have a vulnerability on machine X, or a user has permissions to certain things. There is an up and downside that it's like built and maintained by Microsoft, so you don't have any control over the data in there. It also depends how much you pay them. So depending on the products you basically get, is also limiting what it can tell you, which sounds like a money grab, but it also sort of makes sense, right? If you don't have Defender for Identity, it doesn't know about the potential stuff you have there. So that's a thing. And it only shows what I perceive as what Microsoft determines as a risk. So not every misconfiguration will be in there. It's just certain things that they think are important to you, which can be helpful because it like constrains focus or whatever helps you focus, but it also creates blind spots, which I tend to not like. So it depends a little bit on how deep you want to take it. Also, in my experience, the querying of it doesn't feel like it's in Kusto. It's quite slow, but that might be just my instance. Or I have a lot of vulnerabilities that it has to take into account. But basically what you can see is some data sets where you can see like, hey, a user is a member of a certain group, or some policies aren't properly set, so it's affecting a certain user, these kinds of things. And there's, again, Thomas is going to go into this extensively. So the only thing I was interested in, so it's like what does the schema look like in a way? So now I'm looking at it from the perspective of a user. So you can see all the connections that a user can have for the relationship. So it can have permissions on a lot of blue stuff there, but it can also have permissions on a subscription or have a role assigned via a group, all these kinds of things. So there's quite a big model, and you can take that from any perspective. So now I'm looking at it from a managed identity perspective, which looks very different, but also very similar, because a managed identity can also do all kinds of stuff on all these resources. So it's an interesting thing to look into. And again, this is the last slide, so the rest is going to be handled by Thomas, hopefully. Or I just stole all your stuff. Sorry about that then. Another one that I was curious about, which is more recent and not available to anybody yet for some reason. We even struggle to get it in all of our tenants, is Sentinel Data Lake. What you get when you enable Sentinel Data Lake, just without a choice, is you get a list of tables with all your assets, which is kind of interesting. So you get all your Azure Resource Management stuff, so your VMs, all the other things, and a copy, sort of your Entra. Again, this is built and maintained by Microsoft. It's also periodically updated without any control over when and how frequent, these kinds of stuff. So when I was looking at it several times, it could be sometimes 1 or 2 days old. So for security monitoring and incident handling, not ideal yet. This may be sped up in the future. I don't know what the schedule behind it is. But be aware that if you start using this for whatever you're using it for, it might be delayed. At least they give you the time, right? So when the snapshot is created, and when it was received, whatever that means. I still don't know if that is when it arrived in Lake or when it was post-processed, or doesn't matter. There's a huge time frame between it. That's sort of to be aware of. And the interesting bit here is I tried to create a graph out of it. And one of the things that I noticed quickly is you can see, for instance, group memberships. You can see role assignments. but you don't get any information about the role. So you only get the GUID, which is not super helpful. It's a bit helpful, I guess, if you know all the GUIDs by heart. But if you don't, then you still need an additional source to actually resolve those. And there's a couple of more things. So the good thing, I guess, is it's free. Well, free between quotes, right? You need to enable Sentinel Data Lake, which you don't necessarily pay for until you start ingesting it or querying it. So that's kind of nice. You don't have to maintain it because Microsoft hopefully does that for you. Interesting is that they do have graph support, including graph query language. There's some confusion about openCypher that it might come. I'm hoping for it because I kind of like it. But at least you can use like graph and GQL. When you create a graph like that, you can actually use it in all kinds of alert enrichments, right? So you can actually see, like, hey, what kind of groups is a user member of? What kind of roles does he have? If you have an additional enrichment for those GUIDs. But also, can a certain person access a VM? These kinds of questions you can ask it. But it's sort of the downside for me now is it's like very incomplete. There's no API permissions in there. There's no role assignments, details. There's no permissions-based to access to what is it? A resource. The updates are super slow. I have no control over it. Querying is slow. And maybe the most annoying one for me is there's no API support yet officially. So you can have sort of a user token access thing to the API, but there's no real API to query it programmatically, which you would want to do if you're enriching your alerts, because even with the Copilot stuff, you still need an API, right? So there's no way to easily have access to it apart from doing it by hand. So not ready yet. But again, they launched Lake not too long ago. So there's a lot of improvements that can happen over time. So then the real body of the talk is attack paths. So most people have heard of it, right? There's like every vendor has an article about attack path management. It's just a couple of them. The reason why this makes sense to do something with is this. So let's assume we have a user in our tenant. She's called Aline. She does work, whatever. And we know she's compromised. But now we want to understand, like, hey, okay, what's the impact of this? Like, what can happen if Aline, how long, if she's compromised, what does she have access to? But there's no real way of telling that from, like, the Entra side. And if you know, please tell me, but you can see which group she's a part of, but then you have to go to the group, look at the group, whatever. But if she owns resources or any other stuff, you really can't see that. Where if you do a very simple graph query, you can immediately see she's the owner of a certain app. That app can run as a service principal, and the service principal can do all kinds of fun stuff. Right? So that's like a 2-second thing instead of clicking around in the portal for 20 minutes, going through all your apps, seeing if she has an ownership permission or any other assignment to it, which nobody's going to do. So that kind of sucks. So again, yeah, if you go to the app and you would have known it, then you could have seen, hey, she's the owner of it, right? And owner basically implies she can do anything with the app that she wants. So that's sort of, at some point, why I created FalconHound a year ago, which was a tool that could run all kinds of queries against. In this case, the most examples are like on the left, but like the green ones, like Defender for Endpoint, can talk to Data Explorer or Sentinel, do kinds of queries to see like modifications or log files, like, hey, does somebody just log on to a machine, so I can create a session between those two objects. And I could write that to Neo4j in the past, so I could visualize it with BloodHound and then create fancy graphs that look like this, where this user has a very long but achievable attack path, and there are alerts on that user. So I could basically sync my alerts with my attack paths and actually see if there are new paths or more impactful paths or all kinds of stuff that I need to deal with. And I could do the same with other attributes, like in this case, Defender for Endpoint also does vulnerability scanning. How good it is not important. I think it's quite okay. But these CVEs that it finds are tied to a machine, right? So I can also find, in this case, this machine has some CVEs on it, but there's also a domain administrator logged onto it, or was logged onto it, that also has access to the domain controller. So if I, as an attacker, pop this machine, then I immediately have domain admin access. So that's why also these kind of things make sense. So we have a couple of customers that use this for patch management prioritization, right? So if there is a sensitive path and there are CVEs on it, maybe we should investigate either mitigating the access to that machine or patching it if that is possible. It's not always the case, sadly. So that led me to, of course, the obvious. So Kusto supports Graph. And I really like BloodHound. So I figured, can there be an easy way, instead of exporting from Neo4j and do all kinds of dances, to get the data into Kusto, which is very reproducible for a user. And then I was curious if it could do the same as Neo4j could. So of course, it's like, how hard can this be? It turns out it wasn't easy. I had some failures, many actually. But that's kind of how I like to learn, right? So also, I don't always read documentation, I just try. So the idea was I'll take an AzureHound scan. So I run AzureHound, like the free and open source tool that SpectreOps creates. I run it against my tenant. I take that JSON file, and I basically look at how BloodHound itself. So normally you would import it into BloodHound, and that's a very fancy tool that will do a lot of post-processing. So it will do all kinds of analysis on your data set and create additional edges that you wouldn't get otherwise. This is primarily for performance, but also for visibility reasons. Then I wanted to ingest everything in ADX, because that's the one I wanted to use with. And then I would want to query it with Kusto. So, and ideally, I also wanted to integrate FalconHound, but that's sort of the spoiler, that didn't work yet. So the cool thing about BloodHound is that SpectreOps is super generous in general, but they also share like the full source code of all of their post-processing, all of their ingestion, all of the other stuff. So basically what you're looking at is just one function where they're assigning certain edges to relationships between nodes that didn't exist in the scan data because Microsoft just stores it in a different way. So there's a bunch of things for Azure that they add as additional nodes. So one of them is like you can add an owner permission or these kinds of things. All on the right, these are additional post-processing edges. And the same applies for SharpHound, so basically the on-premise Active Directory scanner. So I replicated all of these things into a small tool that actually could ingest it into ADX, because there I knew that I could have like 3 different query languages to play with. And the additional benefits for me were that ADX is quicker, in my experience, than Neo4j. Also, even though it is a time series-based database, you don't necessarily need to have timestamps in there. I don't know if it hides it, but you can just have it. You can almost use it as a normal database in a way. So that was kind of cool, because especially this data, it is not time series based. Of course, you do a scan at a certain moment in time, but you can also update certain rows. So I can also make changes to it as I would in a database. So then the idea was sort of here where I took these 2 zip files, or at least SharpHound creates a zip file, AzureHound creates a JSON file. In the zip are also JSON files. I basically analyzed all of the post-processing stuff. Then I created an ingester in Go that takes these JSON files, converts it into a way where ADX is also happy with it. So I'm basically creating 2 tables, one with all my nodes, one table with all my edges, and then I defined a graph model that explains to Kusto what it's looking at, so what my graph looks like. So these tables just look like any other table, right? There's a lot of stuff in there. They all have a nice ID, so you can actually link it together. And yeah, it's quite boring in a way, right? But the cool thing here is you can create that graph in 2 ways, as I explained earlier. So you can do a make graph where I take all my Azure nodes and I basically project only the stuff I care about. I do the same with my edges. And then I make a graph where I say, hey, the source ID to a target ID with all my nodes based on ID, which is sort of the unique GUID that links everything together. And within my edges, you can also link those two, right? You can say, hey, ID 1 has membership over ID 2, whatever. You can also do the same here with defining a graph model. So it looks fairly similar, where you can also say, hey, these are my nodes. This is my query. So in this case, I'm only querying the table, so I'm just getting everything. But here you could also say security event where event ID is 4624 for all my logon IDs, so these kinds of things. So you can build a lot of different nodes as well. So it doesn't have to be like one table. You can also have 20 tables. It will be slower, but you can also combine different data sets with this. And this is super cool because then you don't have to remember to write all these queries every time. You can just put it in here, link them together with the right edges, and you would have a really nice model. And then again, you can query that, right? So here I'm just giving it all my data back. So this is my edge, which has all the relevant information to explain what the edge is doing. But this is not very readable, of course. This is just a huge JSON blob. So you can do some funky stuff, primarily in Kusto, and function I haven't seen today yet, to serialize. Then you can basically create these nicer overviews. So you can see Eileen is the owner of a certain app. That app can run as a service principal. That service principal can add an owner to another app. And that app can actually grant the role of something like global administrator. So you can create a whole path in a table if you want, which is super nice. I still struggle with this query language, to be honest, personally. So as Henning announced, openCypher is a thing. So if you like BloodHound already and you're used to Cypher, then you can do the same in a sort of way smaller annotation. And you get similar data back, which is what I prefer. But again, you have 3 options, right? So have fun with it. The only thing I noticed is that, as far as I know, you can't do openCypher directly in the web version of AD Explorer. Unless I'm wrong. Okay, now you can, since it's now actually released. But in the past, you either had to do it over the API or use the Kusto Explorer that I used for this. So that's sort of also the option. If you have a Windows machine, I had to install a VM for that. So another thing that I was curious about, and I need to speed up a bit, is one of the things that you couldn't do in Neo4j is you can add, for instance, additional properties, right? You can do that, but you can actually also do calculations on it. So what I did is I added a weight. So every edge in my ingestion gets a weight that is very arbitrary because I define it. But I can basically say, hey, if I'm an owner, then the weight is 10, so it's very easy to exploit as an attacker. And you can also use that to actually build new queries based on this. When I was querying a lot, I wanted to use some visualization that you saw some screenshots of earlier. But in the web version, there's no graph support. In the Kusto Explorer one, there is a graph support, and I think Henning sort of hinted towards it. I didn't know how to use it because I only got errors, but that's a user fail, right? That's skill issues. So there is a way to use it, but it wasn't necessarily, at the time when I was testing it, what I liked. I played with Graphs3 in the past. It's really cool, but not free. So that's something that then led to this. So I figured, let's create another tool. So what I did is I created a very simple API in Golang, which can talk to ADX in any language you want, or at least those 3. And then I started to create a front end in TypeScript with the library Sigma.js, which is not accidentally the same one that BloodHound itself uses, to actually get some visuals to see if my whole testing worked. So my API is very simple. I just talk to it with a query endpoint, and I give it the language that I want to use and the query that I want to run. So no rocket science there, and I get just nice JSON output. And then I created my own UI, which if you use BloodHound in the past may look a little bit familiar because it's heavily inspired, just uglier. I called it Calypso to stay in the whole Jacques Kusto theme because that was his boat. And this is my vehicle to explore graphs, whatever. I didn't want to name it not BloodHound, which was sort of my first working title, which is funnier, but less respectful, even though I owe everything to them here. So now I can basically have a very pretty graph. And here you can also see the same path where that user has access to app registration, that has access to a service principal, that can actually talk to multiple service principals. And this is by default, right? So I just get all paths that are there, which is super neat. Because what BloodHound does by default is give you one path, and then you mitigate it, you have to query it again, and then maybe you see another one, and this is quicker if you want to resolve some issues. So that's kind of neat about it. So I just showed you a Cypher query, but you can also do Kusto, Kusto query language, or graph query language, which I don't have a screenshot for, but trust me, that works too. When Henning was doing his presentation, I also saw this blast radius function, which looked perfect for my edge weighting kind of example. So I took a very long query, and I ran it over my data set, and it gave me like a bunch of them. So there were a couple more. Again, this is very alpha, right? I didn't really test this, but I noticed that like the first GUID, I was just curious, like, hey, what is this? So I ran that query in my UI again, and I got quite a lot, right? And it still works. It became a bit slow, but it still works quite okay. So I can see that something has a lot of access. So I was curious about that GUID, and it turns out that's the same user as I just showed you with that single path. So that single path can lead to a shit ton more. That's basically sort of what that whole blast radius thing explains, which is kind of cool. So it's actually working. So that's quite impressive. It may have been lucky, right? Because there were a couple of other GUIDs, but that's probably also, I'm in there because I'm a global admin in that tenant. So of course my blast radius is huge. And these are all on-prem stuff. So I didn't look at that yet, but it's pretty impressive. It did take much longer than I'm used to. So this is like 1 minute and 17 seconds, which is still quite quick. But all the other queries I've been running that would crash on BloodHound still work in Kusto, so that's quite impressive. So some things I want to do next, because it's still an experiment, is I want to create like one graph for a lot of my security stuff. I don't know. I know that graph joins are not a thing yet, so I have to be creative about how I'm actually doing it. One of the other things we're building ourselves is sort of risk-based scoring algorithm, where we're scoring every entity related to all kinds of other objects in a customer's environment with a sort of an impact score. So how bad is it if this machine gets compromised and these kinds of things. So I want to embed that into a graph, because we're currently doing sort of graph calculations in Python. That doesn't really make sense anymore. And I also want to look into, so one of the things we also have is a DevOps AzureHound scanner. So I want to incorporate into this, right? So if I compromise a user, I can see that he has access to certain resources or certain repositories or pipelines and these kinds of things. And the same applies to Office. And still want to try to connect somehow these things. Also, everything I showed you is still in my personal GitHub, not shared because it's not as stable as I want it to be. It works most of the time, but still, yeah, if I give it to somebody else, they will probably have all kinds of issues with it. So I want to finish it before I open source them, probably early next year. And of course, I want to also update my FalconHound tool so I can actually keep that model up to date with all kinds of new data. And once there is an API for Sentinel Data Lake, I'll look at that as well, if it makes sense. So I want to sort of thank at least SpectreOps for all of their very gracious sharing of all this stuff, because I couldn't have built any of this myself without all of their knowledge. So at some point, it doesn't make sense for me to also maintain that full UI, right? It was just a fun week of coding stuff that I don't want to maintain for eternity. They have a really amazing tool, so I'll probably look at building some compatibility plugin for like the real BloodHound that it can talk to Kusto as well, which makes way more sense. And then I hope they will merge it, and otherwise I'll keep a fork live, something like that. So that was a lot of information. You may have questions. If not, that's also okay. But I'll happily answer them. Thank you.
question in the Discord.
Ah.
Oh, cool, I'm hearing myself. So basically, from Jeremy, the entry tables you get in Data Lake, does it replace the identity info?
I didn't. The question, if people didn't hear it, so if the identity info table, is that the same, or would it replace the data that is available in Data Lake? Not yet, I think. So yes and no, because there's more in the lake, but also less complete. So there's stuff missing that you would get in identity info, but there's also stuff that isn't in identity info. So I think once it is less previewy, I would say yes. But currently, I wouldn't get rid of identity info, which you will get for free also. So I would use that. And you can actually, the big difference here is also identity info you can actually use within scheduled queries, live queries, custom detections, whatever. The lake stuff, you need to talk to the lake. And the lake you can build jobs on, which can run periodically at an additional cost. But you can't use it in any automatic detection that you want to run. So that's probably the better answer, now I think of it. So, no. Other questions? On the lake stuff, you mean? Or? I think your question is, can you look at like data from subscriptions and other resources in Azure? Yes, you can. So the AzureHound does that already. So if you use the AzureHound data, that basically gets all of your Entra information, all of your resources, if you have it, if you scan it with enough permissions. So if you have visibility into all your subscriptions, then it will generate all that data for you, with the exception of it doesn't do storage accounts, it doesn't properly do contributor rights and a couple of other data components, but it will have key vaults and VMs and a lot of other interesting information. So it's the most complete option you currently have, I think. The only thing now is my tool is not open source yet, so either you have to wait or build your own and go through the same pain. But yeah. Okay, I'll be around the rest of the day. So if you have another question, find me and I'll happily answer it for you. Thank you.